Welcome back. Previously, we developed the test for the transaction output map. So we got to write the actual code to get this test suite back to green. To begin, first up, we don't even have the transaction file. So let's make sure to create that in the local wallet directory. We're going to make this transaction.js file. Let's create the transaction class. And as defined before, this has a constructor with an incoming object. We're passing in a sender wallet, a recipient, and an amount. And at the very end, we want to export this transaction class. Cool. Let's save this and see its effect on the tests. So I'm going to move this to the right. And as we do so, we have more failing tests now that the transaction class is actually available. So first up, the ID does not exist in the transaction. The output map doesn't exist either, which means the related tests for the output map aren't going to be passing. All right, cool. So the first thing that we need to take care of is this ID field. To take care of this ID field, we're going to install a new module called UUID, which as of this course is at version 3.3.2. Go ahead and add the save flag so that way it's saved as the dependency in the project. All right, it's saving. So what UUID provides for us is a way to generate a truly unique value for the actual transaction on its ID field. The UUID module has a few separate modules for different unique ID generating algorithms. So we're going to use the version 1 of this algorithm, and let's require it at the top of the transaction.js file. We're going to make a constant of UUID, which is going to become a function with the result of requiring UUID/v1. Nice. Now, this UUID function in version 1 is timestamp based. And since all transactions are going to take place probably at different timestamps, it gives us a guaranteed way to have a unique ID for the transaction. Therefore, the very first thing that we're going to do is we're going to set ID to the result of calling UUID. As we save this in our test now the next related test is the output map. And as you can see, the object of the transaction itself does contain an ID. Very cool. So let's set the output map as well. And this is going to be an object. All right, nice. So this takes care of the test that ensures that the output map exists. However, we have to add the logic to designate the amount to the recipient, as well as the remaining balance to this wallet's public key. Now, rather than write this logic in the constructor, let's place it within a helper method called createOutputMap in this transaction. This will be called createOutputMap. And then as the argument to this, it's going to take in an object with the sender wallet, the recipient, and the amount. I'm going to enlarge this just a little bit. Cool. Now, as the first line in this helper method, let's create an output map that we can return eventually. The first thing that we're going to do is we're going to designate that the recipient is receiving the amount. So output map recipient is the key, and the value for that key is going to be the amount. Nice. We're going to designate another key for the sender wallet's public key. So output map sender wallet.public key is going to be equal to the current sender wallet's balance. So sender wallet.balance minus the amount. Cool. And the end result is that we're going to return this output map. Very nice. And now that this helper method exists, well, we need to actually call it within the constructor. So we're going to set this.outputMap to the result of calling this.createOutputMap. We'll pass in an object to the constructor, or rather the parameters. We have the sender wallet, the recipient, and the amount. All right, very nice. So as this is saved, we should see in the command line that we have a fully passing test suite once more. We're all green. Cool. So transactions have IDs and an informational output map. The last piece of this is going to be a transaction input. This is where we're going to provide more official details about the transaction. These details include the sender wallet's original balance, public key, and a signature from the sender wallet for the transaction. Now, it's a pretty crucial piece of the transaction because without the signature, in other words, without the input, other users won't be able to verify if the transaction is actually valid. Therefore, we need this part for the transaction to become official and accepted by other users. So fortunately, we've already implemented the signing functionality. Now it's a matter of incorporating this into an actual transaction input object. So let's do that next.